morning, guys. So today we are going to be looking at a new section, which is graphing equations in standard form. Now we've been looking and practicing on how to graph equations in slope-intercept form, which is what we were doing right before winter break. Today we are going to be looking at standard form. So the standard form of a linear equation is ax plus by equals c. And in this form of a linear equation, a and b are what we are going to call coefficients, which is just the quantity that is directly in front of our variables x and y. So a and b are coefficients, and c is a constant, meaning it won't change. It is that quantity all the time. Keep in mind, for an equation to be in standard form, a and b must be integers. In other words, they must be whole numbers. So 1, 5, 7, 9, 13. All right, so a and b must be integers. So to graph a linear equation in standard form, there's one way to do it, which is you can rewrite the equation in slope-intercept form. And that sounds very familiar because, again, that is what we've been practicing for the past couple of days, right? So for your first participation point in the chat, go ahead and answer this question for me. What is the format of a linear equation in slope-intercept form? So let me know in the chat, what is the format of a linear equation in slope-intercept form? So if you have not already, your answer should have been y equals mx plus b, right? Where the m represents our slope and our b represents our y-intercept. So let's go ahead and look at an example. So we're going to go ahead and graph 2x plus 3y equals 12. Keep in mind this is currently in standard form. So our first step is to rewrite the equation in slope-intercept form. So I want to rewrite 2x plus 3y equals 12 in slope-intercept form, meaning it should look like this. So I want to get my 3y by itself, so I will go ahead and subtract 2x from both sides, leaving me with 3y equals negative 2x plus 12. I will go ahead and rewrite that up here. Again, my goal is to get y all by itself, so I will go ahead and divide both sides by 3. My 3's will cancel, leaving me with y equals negative 2 divided by 3 x, and 12 divided by 3 will leave me with a positive 4. So I have now rewritten my equation in slope-intercept form. Step 2 is to plot the y-intercept, and then we are going to use the slope to find another point. So your second point in the chat will be, what is the y-intercept? So looking at my equation in slope-intercept form, go ahead and identify what our y-intercept is. So our y-intercept will be what we call b, is going to be our positive 4 here. And while we're at it, we're going to go ahead and identify our slope, which again is the m. So it's whatever is directly in front of the x. So our m, or our slope, will be negative 2 over 3. So now that I know my y-intercept at 4, I can go ahead and plot my point at 4. And my slope is -2/3, so my rise is -2, so I will go down 2 spaces. And my run is a +3, so I will run to the right 3 spaces, giving me a line directly right here. It's a little off, but it's okay. So I rewrote my standard form into slope-intercept form. I then identified my y-intercept and my slope and used those to plot my line or to graph my equation. So now that we've done that, there's also another way we can graph equations in standard form, and you can also graph a linear equation in standard form using intercepts. Now this idea of intercepts should sound familiar because we've seen it directly in this example when we deal with the y-intercept. So we've always been identifying the y-intercept, and we're just going to add to that idea by also finding the x-intercept. So to find the x-intercept, all we are going to do is we're just going to substitute a 0 for y. So to find the x-intercept, we're going to put a 0 in place of the y. And to find the y-intercept, we are also going to substitute a 0, but for the x. So let's go ahead and practice that. So here we are going to graph -x plus 2y equals -4. And our first step is we are going to find the x-intercept. So to find the x-intercept, I want to substitute 0 for y. So I have -x plus 2. Instead of my y, I will substitute a 0, leaving me with -x equals -4. I want a positive x, not a negative x, so I will divide both sides by 1, leaving me with x equals 4. So now that I know that x equals 4, I can go ahead and plot that point. Again, my point will be given as an ordered pair. I know that x is now 4, and for y, we went ahead and substituted a 0. So my y will be a 0. And this is now the point I can plot as my x-intercept, which is right here at 4, 0. I'm going to do the exact same thing to find my y-intercept, except I will now substitute a 0 for the x, leaving me with -2y equals -4. And to solve for y, oops, this should be positive, I will divide both sides by 2, leaving me with y equals -2. Again, I want to find that point to plot. So for your third point or chat point, what will the coordinate point for the y-intercept be? So it should look in this form, however, it will be a little bit different for the y-intercept. So if you have not already, go ahead and drop in the chat that our coordinate point for our y-intercept will be 0, -2. And then I can go ahead and simply plot those points and connect them to graph my line. Go ahead and pause at any point if you need to reread, rewrite anything, or catch up. Perfect. Now let's go ahead and get some practice applying these two different ways to graph equations in standard form. So looking at our first example right here, it's asking us to graph x minus y equals 5. So again, we have two ways to graph these equations in standard form. For this problem, I will use intercepts. So I will use the method of finding my intercepts. So I will go ahead and start by finding my x-intercept. Again, to find my x-intercept, I want to replace the y with a 0. So I will substitute a 0 for the y, leaving me with x minus 0 equals 5, which will tell me then that my x equals 5. Okay. And my coordinate point, my x we know is 5. And we substituted a 0 for y. So I am left with this point right here of 5, 0, which I can now plot easily right here. Perfect. Now I can go ahead and find my y-intercept. Again, to find my y-intercept, I want to substitute a 0 where I see an x. So instead of an x, I will put a 0. Minus y equals 5, leaving me with a negative y equals 5. But I want a positive y, so I will go ahead and divide both sides by negative 1, leaving me with a negative 5. Again, my coordinate point, take a second, let me know in the chat, what will my coordinate point be for the y-intercept? So, what will the point be for the y-intercept? So since I substituted a 0 for x, I will have a 0, and my y is a negative 5. So I can then plot that point of 0, negative 5 right here. And I can connect those dots. Just like that. Perfect. Let's go ahead and try one more. Also using intercepts again. Using intercepts. So I will find my x-intercept first. Can you guys let me know in the chat? To find my x-intercept, will I substitute 0 for the x or the y? So when I find my x-intercept, will I substitute my 0 for the x or the y? So I want to substitute that 0 for the y since I want to find the x. So I'm left with 6x equals negative 3. I want my 6 alone, so I will divide both sides by 6, leaving me with x equals negative 3 over 6. Now notice that negative 3 over 6 is a little bit hard to graph. So notice that this can simplify to negative 1/2, giving us a point of negative 1/2, 0, which is a little bit easier to plot because it is halfway from 0 to 1. Now the y-intercept will be the exact same thing, except now I am substituting 0 for x. So 6 times 0 minus 3y equals negative 3, leaving me with negative 3y equals negative 3. I will divide both sides by negative 3, leaving me with y equals 1 and a point of 0, 1, which I can plot easily right here. And then I can go ahead and connect those as well. Perfect. So that is how to graph equations using intercepts. Now looking at our last two examples, I will go ahead and use the method of using slope-intercept form. So I will use slope-intercept form method. Meaning I want to rewrite this equation in standard form and rewrite it to be in slope-intercept form. So how to do that is, again, I want it to be in this form of y equals mx plus b. So I want to get this y all by itself. So I will go ahead and subtract that x from both sides, leaving me with 2y equals negative x plus 2. Your next point in the chat will be from this question. What is the last step to get the y by itself? What do I need to do to get y isolated or on its own? Perfect, I will go ahead and divide both sides by 2 since 2y is technically multiplication, leaving me then with an equation in slope-intercept form of y equals this negative 1x divided by 2 will give me a negative half x like that plus 1. And now this is exactly what we've been practicing for the past couple of days, where we can identify then our slope, m, again, is that number directly in front of the x, which is a negative 1/2, and our y-intercept b, again, is that number right here, which is a positive 1. So I know my y-intercept is at positive 1, so I can plot a positive 1. My rise is going to be a negative 1, so I will go down 1 space, and I will run a positive 2, which is 2 spaces to the right, which would lead me right there. And I now have 2 points that I can connect to draw my line. Awesome. One more example where we're going to try this slope-intercept form method again of graphing. So again, I want to rewrite this standard form into a slope-intercept form. So to do that, again, I want to move this 4x, so I will subtract it from both sides, leaving me with 2y equals negative 4x minus 8. And similar to the previous example, I'm going to go ahead and divide 2 on both sides to get that 2 completely isolated, which will leave me with a slope-intercept form equation of y equals negative 2x minus 4. So now that we have our slope-intercept form, your last chat participation point is going to be, what is b, or the y-intercept, and what is m, or the slope. Again, m is that quantity right in front of our variable x. So m is a negative 2, so our slope is a negative 2. And our b, notice, is going to be a negative 4. We are going to bring that sign in front of it. So our whole y-intercept is that entire negative 4. So I will plot my y-intercept at negative 4. And my slope of negative 2 is the same thing as negative 2 over 1. So my rise is a negative 2. And a run of positive 1, giving me my point right here. And I can now connect these dots to draw my line. So we have just practiced graphing equations in standard form using a method of intercepts and the method of rewriting it in slope-intercept form.